Astronomers recently made a thrilling discovery using the James Webb Space Telescope. They captured an image of the exoplanet AF Leporis b, a gas giant orbiting its parent star. What makes this observation extraordinary is the race against time to capture it before the planet became hidden behind its star for a decade. This achievement marks a significant milestone for Webb's capabilities. In this video, we'll dive into how Webb made this observation, why it's a game changer for exoplanet research, and what it could mean for future discoveries. So without further ado, let's get started. All right, let's start with why the timing was so critical. AF Lep b orbits its parent star AF Leporis, which is about 88 light-years away from us, pretty close in cosmic terms. The planet is around 3.2 times the mass of Jupiter, and it's in a rapidly changing orbit. Currently, it's about 8 times the distance between Earth and the Sun from its star, but this orbit is bringing it closer to the star from our point of view. Now, here's where the race begins. Webb's team had a small window to capture the planet because, as it moves closer to its star, the planet will disappear behind the blinding light of its parent star for potentially a decade. Why couldn't astronomers wait? Well, AF Lep b has a 25 Earth-year orbit, and this means that once it's hidden, it would take more than 10 years before we could get another clear view. Webb's team needed to act fast, and they certainly did. Using its coronagraph, they blocked out 90% of the star's light to make the planet visible. Now that Webb has imaged the planet, what did it actually find? F Lep b isn't just an ordinary gas giant. Its atmosphere is bursting with activity. The data showed something surprising: much higher levels of carbon monoxide than expected. Carbon monoxide is interesting because it's typically found in the lower atmosphere of gas giants like Jupiter, but in this exoplanet, it's present in the upper layers. This hints at some pretty intense atmospheric dynamics. The high carbon monoxide levels indicate that convection currents, essentially giant atmospheric storms, are at play. These currents mix gases between the lower and upper levels of the atmosphere, making the atmosphere incredibly dynamic. We've seen evidence of similar weather phenomena in other gas giants, like WASP 39b, where Webb also found intriguing atmospheric patterns. What makes its atmosphere stand out is how young the planet is. It's just 23 million years old. To put that in perspective, Earth is around 4.6 billion years old. This means we're looking at a planet in the very early stages of its life. Studying its atmosphere can give us clues about how gas giants form and evolve over time. Are these atmospheric processes typical for young gas giants, or is AF Lep b a unique case? That's one of the big questions astronomers hope to answer with more observations. The observation of AF Leporis b is a significant milestone in exoplanet research because it successfully pushes the limits of what the James Webb Space Telescope can do. It's one of the minor planets directly imaged, and until now, it wasn't clear if planets this close to their stars could be captured due to the overwhelming starlight. This breakthrough is now about detecting planets' atmospheres, not only discovering planets. Take AF Lep b's atmosphere, for example. Webb revealed that its atmosphere is far more dynamic than expected, with convection currents mixing gases between its upper and lower layers. These kinds of findings allow us to peek into the mechanics of how gas giants form and evolve, providing clues that can be applied to similar planets. In the case of HIP 65426b, Webb was able to capture another gas giant using its coronagraph. While it is significantly larger, the data collected by Webb on both planets offer a detailed comparison of atmospheric behaviors. Moving on to the TRAPPIST-1 system, which features 7 Earth-sized rocky planets orbiting a dwarf star, we see an entirely different type of planetary system. While TRAPPIST-1 is very different from AF Lep b, The ability to study a system with a wide variety of planets will provide rich comparisons for understanding how atmospheres differ between rocky worlds and gas giants. Scientists can learn more about habitability by studying these atmospheres, especially in systems where planets may reside in the habitable zone. Then, we have the PDS-70 system, which offers another fascinating look into gas giants. This system is unique because its two gas giants are still in the process of formation, surrounded by a protoplanetary disk. Observing these planets allows us to see how they interact with their surrounding material, giving us insights into how planets grow and how their atmospheres develop. Understanding the similarities and differences between forming planets in PDS-70 and older planets like AF Lep-B will deepen our knowledge of planetary evolution over time. Looking to the future, Webb is set to observe even more extreme planetary environments, including hot Jupiters, which are gas giants that orbit extremely close to their stars. These planets are subject to intense heat, leading to wildly different atmospheric dynamics than what we see on planets farther from their stars. By gathering more data from these varied exoplanets, we can build a complete picture of planetary evolution and uncover some of the ingredients for life. JWST's observations of planets like AF Lep-B revolutionize our understanding of the universe. They offer us new ways to investigate planets beyond simply detecting them. We can now study their atmospheres, dynamics, and formation processes in unprecedented detail. Thanks for watching. Please like and subscribe for more updates on the latest space news.